So what we're going to look at in this video is a set of characteristics about functions. And those words to describe this characteristic would be the words domain and range. So this is just one of the many characteristics you can look at involving functions. You'll explore this much more in depth in Algebra 2 and leading into pre-calc. But when we're talking about domain and range, think, what do we know about functions already? We know that functions deal with, the definition has to deal with the input and output values. So when we use the words domain and range, what they literally describe is your input and output values. So the domain would be the set, in other words, the group of all possible input values. The domain is dealing with the input values. What are my possible inputs to this problem? And then the range would be the set of all possible output values. So again, when we think about input and output, we think about normally our independent, dependent variables, your x and your y. So the domain would describe all your possible, shortcutting it would all your possible x values, and the range would describe all your possible y values. So we looked at this example in class about the track meet scoring system. So if I were going to identify the domain, it would be all of these input values. So first, second, third, and fourth place. And then the range would describe all the possible outputs. 5, 3, 2, or 1 points. If you think about the mapping diagram, the domain would just be everything that's in the first bubble, and the range would be everything that's in the second bubble. So that mapping diagram can kind of help you visualize domain and range. So when we talk about domain and range, normally we're not going to just pull it off of these simplified examples. We'll be thinking of graphs and equations, and that's what you'll be heading into more when you talk about going into Algebra 2. But when we do notation for domain and range, it's not as simple as just, the accepted notation isn't as simple as just listing out numbers all the time. For instance, this example, this mapping diagram, gives you your input values and your output values, but when we talk about input and output, they're not always just a list of numbers. But anyway, we're talking about notation. There's two different types of notation, and one is called set notation, and the other, which I'll just briefly talk about, is called interval notation. Set notation is what we're going to prefer to use at this point. I just wanted to give you a little preview of interval notation because you'll see it in Algebra 2. Set notation involves listing the domain, and I'm just going to use D for domain and R as range, defining what is in the set, in other words, what's in the group that we define as the domain. To use set notation, we use the little curly brackets, and if you're looking at your computer, if you're pressing the shift key, it's by the letter P on the right side. The curly brackets actually tell you that you're grouping this set of numbers. You're saying this, between the curly brackets, is a set of numbers that has this characteristic. So in this case, we're talking about the domain. The domain is, and this notation is common for what you'll see. This is saying the domain is all the x values, and this little colon here means where. And this blank is where you're going to describe the x values you have. So in this case, for my example I have, what do I know about my x values? Well, I have these x values. I have the values x is equal to -4, -8, 4, and 5. What other kind of notation could I see though? And you'll see this in our examples upcoming. Maybe x isn't just singular values. Maybe x is all the numbers that are greater than a certain number. X is greater than 5. It includes everything 5 and above. Maybe it's everything is x is less than a certain number. Or what if x could be any possible number that you want? You would use some notation, and the notation is what we're going to have to get used to. It's not that difficult, but if you wanted to say that x could be any possible number that we know of, you would say x is, and these symbols say, right here, I'll group them together here, not this last symbol that I'm drawing. This means that x could be anything in the real numbers. So this E and this capital R, this block R, would mean that x could be anything in the real numbers. You can use inequality signs, you can use equal signs, and we'll see the different cases where you'd want to use each type. The range would be very similar. Again, it would be y. The only difference is we're talking about the range, we're talking about the y values. So it's y where, and in this case, we have y equals 1 or 2. But it could be something where you're saying y is greater than or equal, or maybe just greater than. Y is less than. Or, again, y could be a part of your range values, could be any possible value. You're not restricting them at all. On second thought, we're going to stick with set notation right now. I may mention interval notation in class, but for right now, set notation is pretty much a good jump for you, a good jumping off point. So we can use inequalities, we can use equal signs, we can use, say it could be anything. It just depends on our situation. So just remembering the definition. Domain is all the possible values. So for instance, I'm going to do this one, finding the domain given this function. And I've defined this as a function. Again, if you think about your vertical line test, every input has only one output, so therefore this is a function and I named it as such. If I want to give the domain and the range, and actually I think, oh, yep, I had words there. Oh well, we can cross those out. Again, your notation, you want to start with our squiggly lines and our y and x colon. That just says we're defining the set. Domain is x's, all x's, where, and then we're going to fill in the blank to describe it. So if you look at this graph, you think about what possible x values are included. Well, let's look at the x values that are shown on the axes. If I said that x is equal to 0, if I asked you on this graph, when x equals 0, what is y? If you look at x equals 0, there's no y value that goes along with it. So the domain does not include zeros. It does not include 0 as what x could be. When does it start including our values? Well, if we're talking about the domain, we're talking about left and right. We're talking about the x-axis. What x values do I have included on here? Well, it looks like, and you can use these lines to kind of help you. I'll show you tomorrow where you can do this with highlighter and it's a little more effective. But it looks like we start doing x values at positive 1. Do we keep going forever and ever? Well, no, we stop. It looks like at this point. So what possible x values do I have? Well, I definitely have 1, 2, 3, 4, and 5. But do I have values in between there? What about 4.5? Well, there's a point. What about 2.1? There's a point. The points in my domain would be any possible x value. What possible x values do I have? Well, it looks like I have any number between 1 and 5. So if you remember with our inequalities, how can we show that? Well, this would be, because we're saying x is between 1 and 5, this would be a compound inequality. Does it include 1 and does it include 5? Well, if you looked at the original graph, these were filled in circles. Excuse me. So describing what values x could have, we want to use an inequality, a compound inequality in this case. How about for the range values here? Again, so these are the y values. How low does my y values go? How high do they go? Where can I have y's? Well, again, so using these lines to help us. If I put these horizontal lines, you can see that the y values that we have fall in between those two. I've basically boxed in my graph there to help me define the domain. So these would be x values, and these would be y values, and the range. So what is the range? If you were going to describe the range to me, what possible numbers do I come out with for y? Well, 3 is definitely in there, 3.1, 3.2, 3.3, on and on and on up to 4. So what are the possible range values? Well, just those that fall in between 3 and 4. So domain and range are going to take some practice, are going to take some time. This is the I do. I'm just giving you one you do to try on your own. You want to try and think, and this format is very, very common. I gave you just the inequalities on the previous page, saying that the notation could include inequalities. When we talk about doing your notation, generally speaking, you're going to see a lot of compound inequalities. So I want you guys to try this one. And again, this is a problem we saw in class today. Give me the domain and give me the range. So the domain, if you haven't paused it and try it. The domain, again, what possible x values do you see? So if we go along our x-axis here, it doesn't extend into, so this is 3, 4, 5. If I go to -6, there's no y value associated with that. When do I first start seeing y values? Well, when x is equal to -5, it looks like that's my first time. If I keep moving along, -4, -3, -2, -1, 0, 1, 2, 3, 4, up at 4, my graph is ended. I'm moving along the x-axis. So where are my values for my domain? In this case, -5 is where it starts. Does it touch -5? Yeah, it includes -5, so I'm going to use the equal. The x values fall between -5, and then on the right end here would be +3. For my range, again, y where? And then we fill in the blank. What are the possible y values? So if I look at y is -3, nothing there. Y equals -4, nothing there. When do I start seeing y values? Well, I don't start seeing y values that are on my graph, or part of my graph, until I get to -2. If I keep moving along, there's no skips. -2, -1, 0, 1. And then once I get to 2, it's gone again. So what's the highest number my y values go to? Would be +1. So my y's fall in between, and this is my notation to say the y value could be between -2 and +1. We'll discuss further talking about domain and range. This is just a basic overview of, because there's a lot of information with notation, I want you to just kind of take these two examples and think about them. We'll be working with graphs tomorrow, and working more with domain and range, looking at word problems and things of that nature, equations as well. So notice, though, I just want to point out one other thing about this. Said in class, this was not a function. So notice I didn't call it it's not called a function, it's a relation. So just to kind of point that detail out. But domain and range basics. Domain, x values, describe the x values. Range, describe the y values.